All right. So, hello everyone, and welcome to this talk. We are gonna talk about generative AI. We know that it's new and exciting, but conversational design principles are forever. Here with me, I have Alessia.
Hello, everyone. Thank you for joining us today. My name is Alessia, and I work as a cloud consultant in Google Cloud Professional Services.
Awesome. I am Savi, and I am a Google developer expert in conversational AI. And feel free to follow us in our social media. And today we will start by talking a bit about divergence and convergence in the context of communication. We will then compare large language models and virtual agents. Afterwards, we will review together some good practices and pitfalls to keep in mind when designing conversations and how we can mix up deterministic and generative features in Vertex AI conversation and Dialogflow CX. Lastly, we will demo a multimodal conversation with a virtual agent that combines deterministic, intent-based design techniques with generative AI features. So, we would like to start this session by talking a bit about divergence and convergence in the context of communication and explain the difference between open-ended conversations that helps user learn versus goal-oriented conversation that help users solve a specific problem. And we will keep this in mind as it relates to designing virtual agents in Vertex AI Conversation and Dialogflow CX. So imagine a conversation where we delegate the whole user agent dialogue to a large language model. For example, using Vertex AI Gemini API instead of Dialogflow CX. It becomes an open-end chat that always seems to diverge instead of converging towards the problem resolution. If you're actually trying to solve a problem, like reporting a property damage, as it is, as you can see in this example, what seems like creativity and open-ended possibilities may turn into a frustrating user experience. On the other hand, if we were to only use deterministic intent-based design in our Dialogflow-based chatbot, it might get the job done, but users would feel like they were working with an impersonal robot rather than a helpful assistant. We will break the two concepts of generative text and deterministic agent design in two components: creative, expressive conversations, in other words, divergence, and focused problem solving conversations, in other words, convergence. So, convergent thinking focuses on reaching one well defined solution to a problem. This type of thinking is best suited for tasks that involve logic as opposed to creativity, such as solving a problem where you know there are no other possible solutions. In this vignette, for example, these two people are discussing a bit about going out for dinner and then lastly agree on cooking at home. Due to the ability to steer conversations and make transactions, virtual agents are quite good at this part of the conversations. On the other hand, divergent thinking is completely the opposite of convergent thinking and involves more creativity. There are certainly advantages related to divergent thinking. It can help you identify new opportunities and find creative ways to solve problems. However, as we can see in this vignette, divergent thinking might take these two people far away from reaching a common goal due to their generative nature. Large language models are quite good at this part of the conversation. So basically, both are good. We are not telling you that you have to choose one or another. When we are designing conversations with users, we want to ensure that we are divergent when it comes to options and possibilities, and convergence when we are trying to help them to solve a problem or make transactions. In the rest of the session, we work through specific examples of blending generative language from Vertex AI Gemini API with deterministic agent design in Vertex AI Conversation and Dialogflow CX. So for instance, let's take this another example. Here, what happens when we design a virtual agents to be convergent and only help users with a specific goal. In this example, the user's goal is to book a live board for his family. Notice how the agent is not too prescriptive. However, thanks to large language model, it does handle an unexpected destination, as well as the user intent to take a scuba course. It resets expectations about what is and what is not possible and steers the conversation back to the successful path, back to the happy path. It would be extremely hard and almost impossible to design an agent to handle this myriad of unexpected user inputs. That's when generative AI comes into play. So now let's put our best practice into action and design a blend of deterministic goal-oriented conversation. Um, and we will see how the agent is designed to switch to a generative and large language model-based approach when it's appropriate. Once the question is answered or the distraction is over, the agent returns to helping the user with the primary goal. So now that we have explained the importance between or the two concepts, creativity and determinism, let's talk about generative AI in conversation. Alessia, can you please explain this concept to us?
Thank you so much, Chavi. Great introduction. So before we dive into the tools and the features that we have available to use generative AI in conversation, I first want to talk a little bit about large language models and the differences between large language models and visual agents. What are LLMs? LLMs are models that have been pre-trained on a large corpus of data and that learn billions and billions of parameters to be able to generate and understand general purpose language. Now, let's see actually what the difference is, because at a first glance, people might just think, okay, well, just as you showed us before, we can just drop in, replace virtual agents with LLMs. But can we actually do that? No, because as you explained very well before, LLMs are typically generalist. They're being trained on a large corpus of text. So to begin with, they might not be able to provide the most recent, the most accurate information because it takes a long time. It's a very time-consuming and costly process and to retrain a large language model. On the other side, in fact, we also see that visual agents can call out to LLMs to retrieve information. So now it's up to how we design a virtual agent to when we want to leverage LLMs, or when, on the other hand, we want to be prescriptive, as you said before, about the actions that we want to do, like going through, like acquiring a set of parameters to be able then to fulfill or call a backend service. So in the next slide, we now see, in fact, how in Vertex AI search and conversation and Dialogflow CX, we have a large spectrum of features available, where on the left-hand side of the spectrum, we have fully deterministic capabilities like the ability to create intents, provide training phrases, or create entities. So whatever we know, or whatever we are familiar in with Dialogflow CX, to be able to create deterministic flows. Then on the other side of the spectrum, we have fully generative content, like chatting with the Gemini APIs, or virtual agents created using generative playbooks and structured data. So the virtual agents created using natural language. And in between, we have features like a data store agent that allows us to create a virtual agent on top of a knowledge base, which is powered by large language models, to be able to respond to user queries about the content stored in the knowledge base. While the features like the generative playbook and generators, they still rely on LLMs. Okay, so let's talk a little bit about actually how data store agent works. So we said it's one of the recent generative AI features that we've added in search and conversation and Dialogflow CX. In fact, it actually spans across these three. Okay, so first, how do we use it? So as I said before, let's imagine we want to index pages from a website, from a public website, hundreds and thousands of pages, or we've got structured data in a Google Cloud storage bucket, or we've got a database. We've got a data source. So we're able to generate an agent which has been configured to be able to respond to user queries using the knowledge base of the data store. That agent is powered by a large language model. How does it work? When the user sets something, so let's say the query is, can you help me choose the most suitable mobile plan? We're able to detect the intent and actually determine, which Dialogflow determine that we can answer the question using the knowledge in the data store. So now this prompt augmented with optional additional user information. So that's how we're able to inject personalization in the prompt. Is augmented with the results with what Vertex AI search has returned from the search into the data store. So these augmented prompts document user query and potential other, and the conversation itself, so all contextual about the user query is sent to LLM that generate a response. This response is as we said, is contextual, it's grounded to knowledge base. And it's also, comprehensive of potential links of where the answer was found in a page or in a PDF document or in a document. So what we return back to the user, it's a summarization of the response itself, plus, additional links to the pages, the documents themselves. Okay, so now let's have a look at the order, what we call the order of evaluation. So how the life cycle, the traditional life cycle of a page in Dialogflow meets all these new generative AI features. So as we mentioned already, the first thing Dialogflow CX attempts to do when a user input comes in, so when the user says something, is try and pre-fill any form parameters at that page where we are as part of the as within the dialogue. So let's say that there are any parameters, we will try to extract them and fill in those slots. Otherwise, as we are used to, we will look for an intent in scope for the page, and if the user input matches the intent, it will fulfill the intent either in a traditional way, like calling a webhook, or maybe using a generator if a generator has been attached. See, a generator has just like a free prompt, LLM prompt, that ultimately makes a call to either the Gemini API or another large language model to do question answering or other tasks. Again, if this actually second step, if the agent has been designed to handle that intent, it will look for the answer. So it will do the question answering using the knowledge base provided. If there is a knowledge base, if there's a data store and on that page. And remember the flow that we just seen in the previous slide. Otherwise, we are in what we call a no match scenario, when the user input didn't match any prescripted intents, or it didn't find any results in the data store. And that's when generative fallback comes in. Generative fallback is a way to handle unexpected input and to steer the conversation back on track. So rather than give an answer like a minimum viable answer, like, oh, sorry, I didn't get that, we want to be cooperative with the user and try to restore the conversation. Great. So having said all of that, we want to share with you some guidelines and, in a way, also pitfalls. Xavi explained before that you guys might see when you start using LLMs in the context of conversational AI. So let's begin with the first one. Okay. As I said before, LLMs have been trained on a large corpus of data, but we need to be also, and many times they're actually able to provide accurate answers, but not always, especially when the answers have to be when the answers need to be found in a specific knowledge base, or if they are related to an organization, or they're very time sensitive in a way. So that's when we have to fall back in a way. And that's when LLMs need a knowledge base. So that's when retrieval augmented generation comes in, which is the ability to tap into additional data resources on top of LLMs. And that's what exactly Data Store Agent does. As Xavi mentioned before, always remember that LLMs tend to diverge by nature, that's their nature. But when it's time to help the user solve a problem, we want to be convergent, and rather than talking about options and possibilities and raise the user frustrations, we want to help the user really solve a problem. So design your agent to be able to first help the user solve the problem. And then last but not least, remember that generative fallback is a great, it really comes handy in there. Let's say sometimes even a huge bucket of unexpected detours, or even common detours. So because it's so hard to design the agent for all those scenarios and conversational paths, so remember to fall back to LLMs. Xavi, do you want to walk us through the other three?
Yeah, for sure. So the other basically guideline is mix deterministic design capabilities and creative generative features to cover a wide range of user journeys that involve information retrieval, troubleshooting, and transactions. Basically, as we said, is this means that we have to mix and use both capabilities, being convergent at the same time that we are divergent as well. And this goes to the next one, which is basically inject generative content into your chat and voice bots to help gain user trust. And the most important thing here is to make experiences a bit more human. We have to put a focus to have like the best user experience and to know that the users are or that the users know that they are not interacting with a chatbot, that they are interacting with a human. And then last but not least, this is an important point, and it is basically to be also aware of the potential security threats related to large language model based applications that process very sensitive users' inputs since they are subject to prompt injection. So with that being said, we just wanna continue with the goodbye graffiti demo that Alessia is gonna be demoing. So let's
yeah. So yeah, definitely. So before we actually play the demo itself, folks, I just want to give you a little bit of a background of what features this demo uses, and how we actually put them together in action. Okay, so it's a demo about as we said before, reporting a graffiti issue. So a person will try to report a graffiti issue, but you'll see how in addition to going through the steps needed to collect the parameters required to in fact report the graffiti issue itself, as it's quite normal and expected, the user will try to detour a couple of times, and you see how generative fallback always takes the user back on the successful path. We always try to attempt to do that. And then generator is used a couple of times in the conversation at the beginning and at the end, and you see where actually we use that. And then last but not least, I want to highlight that the demo uses Co-Companion, which provides a multimodal conversational experience. So it puts together visual elements and text, and provides real-time speech to text and text to speech. And that, last but not least, the demo also calls Google Maps platform, the Google Maps API, to be able to look up the latitude and longitude of the location of the house and display it on the map. Let's watch it.
Let me click on play.
Hi there, I'm Mel, the helpful virtual agent for the residents of the city of Mel. I can assist with a variety of matters across the city, including reporting an issue, paying a parking fine, booking a hard waste request, or just letting you know what's on in Mel. How can I help you today?
Hi, I need to report a damage to my property.
I am very sorry to hear about the damage to the property. I need to ask you for a few details so we can get started on cleaning it up. First, what's your address?
Give me 1 second.
Sure, take your time.
Thanks. The exact address is 38 Knott Street, Port Melbourne, Australia.
Thanks, I have collected the final address. Is that correct?
Yes, that's correct.
What has been vandalized? Can you describe the damage? Thank you for your report. We have received your report about the scratched and painted garage door at 38 Knott Street, Port Melbourne, Vic 3207, Australia. We will investigate the matter and take appropriate action.
Thank you.
In case we need to follow up on this case, we will call you on this number. For now, thank you and have a great day.
Fantastic. Okay, Toby, do you want to tell us how we can potentially download and install this demo, and what else? Well, what are learning resources we have available?
Absolutely. So here in this slide, what you can find is basically the goodbye graffiti, the one that we just showcased. There are other resources like everything related to generative AI on Word Cloud. Check it out. And there's also all the things that we have covered today. Alessia, in her Medium, she wrote a really good article that basically puts everything together. So if you want to check that out, you can just go there and read that article, and in case that you have like any doubts. And with that being said, thank you everyone, and yeah, remember to follow us on social media, and we are gonna be here happy to answer all your questions. Thank you everyone.
See ya.